Swedish researchers just cracked a major engineering challenge that's been limiting the scalability of quantum computers. They've made quantum amplifiers 90% more energy efficient, and this isn't just a nice-to-have improvement. It's removing a real bottleneck that gets worse with every additional qubit. Here's why this breakthrough matters for the quantum computing industry. Quantum computers are incredibly fragile. Unlike your laptop that runs fine at room temperature, quantum computers need to be kept colder than outer space to function. But here's where it gets really tricky. To actually read information from qubits, you need these super sensitive amplifiers. Think of them like ultra-precise microphones trying to pick up whispers in a hurricane. The problem though, these amplifiers generate heat, and heat is the enemy of quantum computing because it causes something called decoherence. Basically, your qubits lose their quantum properties and your computation fails. It's like trying to maintain a house of cards while someone's running a leaf blower nearby. Enter the team at Chalmers University in Sweden. They've developed what they call a smart amplifier that only turns on when it's actually needed to read a qubit. Instead of running constantly like a car engine idling, this amplifier operates in pulses, turning on for just 35 nanoseconds when a qubit needs to be read, then switching off again. Here's a neat thing about this. They actually use genetic programming to make this amplifier respond incredibly fast, and this resulted in a 90% reduction in power consumption compared to the best amplifiers we had before, with zero compromise in performance. But this isn't just about saving electricity, though that's nice too. When you're building quantum computers with hundreds or thousands of qubits, each one needs its own amplifier. With traditional amplifiers, the heat from all these components would literally destroy the quantum states you're trying to preserve. This breakthrough removes that roadblock. This is actually a bigger deal than what it might sound. Thermal management from amplifiers becomes exponentially worse as you add qubits. With traditional amplifiers, the heat from hundreds or thousands of them would basically cook your quantum states. This breakthrough removes that scaling nightmare. We're talking about enabling quantum computers with significantly more qubits than what's practical today. More qubits means exponentially more computational power, the kind that could tackle problems in drug discovery, material science, and optimization that are impossible for classical computers. Now, quantum computing still has major challenges to overcome: error correction, coherence times, and control systems. But thermal management was becoming a serious wall for building larger systems, and that wall just got knocked down. That's genuinely significant progress for this industry. Let me know what you think about this in the comments. Thanks for watching.